Hello again, scholars. So yesterday we went over benchmarks. Today we're going to do a little bit more with benchmarks, and then we're going to also incorporate equivalent fractions. But first, let's write the fractions in ascending order using benchmarks. So I provided 3 fractions for us. The first one being 3/8. Now, is 3/8 close to 0, 1/2, or 1/2? It's close to 1/2. Very good. So how did we get that? Why do we know that it's close to 1/2? Well, we know that 4/8 is the same as 1/2, and 3/8, well, that would just be around here because it's 1 less than 4/8. So we're going to put down 3/8 here. We're at 3/8. Okay. The next fraction we have is 7/12. Is 7/12 close to 0, 1/2, or 1/2? 7/12 is close to 1/2. Very good. How do we get that? Well, the halfway mark, if we were dividing this number line into 12ths, would be 6/12, because 6 is half of 12. And 7/12 is a little bit bigger than 6/12. So 6/12 would probably be around right here. 6/12. Oops, I should have said 7/12. 7/12. We'll go with it. 7/12. All right, the last fraction we have is 1/9. 1/9. Is 1/9 close to 0, 1/2, or 1/2? 1/9 is close to 0. Very good. How did we get that? Because the numerator is really close to 0, and it's really far away from the denominator. For instance, if the denominator is really big and the numerator is really, really small, we're going to know that it's closer to 0. Okay, so 1/9 would probably be around right here. 1/9. So if we wanted to write these in ascending order, and the difference between ascending and descending, a way to help me remember descending, the letter D, and descending, I remember the D and descending for down. But we're going to be doing ascending. So we're going to be going up. From least to greatest, we're going up. So ascending order. So we're not doing descending order, we're doing ascending order. All right, so the smallest fraction we have is 1/9. We said was 1/9. The next one we said was 3/8. And the last one we said was 7/12. So these are our 3 fractions in ascending order using benchmarks. All right, so we're going to do another example. For this example, it says, order the rational numbers from least to greatest. If we look at the first number, we have 6/10. 6/10. Is that close to 0, 1/2, or 1/2? 6/10 is going to be close to 1/2 because 5/10 is the same as 1/2, and 6/10, well, that would be about right here. So we're going to write down 6/10. All right, the next number, 3/100. So that means if we were looking at 3/100 and this was all divided up equally, we would have 100 parts. 3/100 would be all the way over here, somewhere in this region. So we're going to put down 0.03, and we would say that as 3/100. And the last number we have is 8/12. Now 8/12, is that close to 0, 1/2, or 1/2? Well, we know it's not close to 0 because we know it's greater than 1/2. We know that if this was divided into 12 parts, the halfway mark would be 6/12. 6/12 is the same as 1/2. And 12/12 is the same as 1/2. Now, our number is 8/12. If we were to divide the upper portion evenly, right around here, what would that be? If this is 6/12 and this is 12/12, this would be 9/12. Our number is 8/12, so we know it's going to be about right here. 8/12. Now our directions say to order them from least to greatest. That's the same thing as ascending order. So we're going from least to greatest. So our smallest number is going to be 3/100. The next number is 6/10. And our last number, going in ascending order, is going to be 8/12. So using benchmarks, we were able to determine our ascending order for these fractions, or for these numbers. Great job, guys. All right, so earlier in this lesson, I mentioned that we were going to go over equivalent fractions. Now the rule for equivalent fractions is that it can only be made by multiplying or dividing, and whatever I do to the numerator, which is the top, I also have to do to the denominator, which is the bottom. So whatever we do to the top, we gotta do to the bottom. What we do to the bottom, we gotta do to the top. Okay, so this is going to be an example of equivalent fractions. I'm going to divide this one circle in half. And let's just shade one portion of it, okay? So for this, in the beginning, we had 2 halves, and I shaded one of those halves. So I shaded 1 out of the 2. So the shaded portion represents 1/2. Okay, now I can do the same thing here. What if we divided it in half, but divided it in half again? I'm going to shade this portion. Now we have 4 sections, 4 parts, but how many parts are shaded? 2. If you look, they look the same. We have 4 parts here, but 2 are shaded. We have 2 parts here, 1 is shaded, but they're both equivalent. So to do that, we did 1 times 2 to get 2, and 2 times 2 to get 4. Well, if we took it another step further, did not do that in the middle. Okay, there we go. And let's do it this way. And we shaded it. Now in total, we have 8 parts, but 4 are shaded. All 3 of these circles are equivalent. Some circles have more parts and some have less, but the amount that is shaded is the same. So all 3 of these circles and all 3 of these fractions are equivalent. So if you notice 5 and 10, what could I do to one of these fractions to make the denominator the same? I can't break this one down because this one's already in simplest form. But this one over here, could we do something to this fraction to make the denominator 10? Yeah, we can multiply it by 2. So if we take 3/5 and multiply the denominator by 2 to give us a denominator of 10. But remember, the rule says that whatever we do to the bottom, we also have to do to the top. So 3 times 2 is 6. This means that 3/5 and 6/10 are equivalent. So 3/5 and 6/10 are the same. Now if we compare 6/10 and 3/10, which one is bigger? 6/10 is bigger. So if we were to write this out, if I were to bring both of these down here, put these fractions down here, we have 3/5 and 3/10. Which one is bigger? We determined that 3/5 is the same as 6/10, and 6/10 is bigger than 3/10, so 3/5 is greater than 3/10.